Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this, but when I title it, that's how I'm going to title it when I title it. But what I am sure of are our 3 goals for the day. Our first goal is going to be to introduce what a compass is and a straight edge is. Our second goal is going to be to copy a segment. And our third goal is going to be to copy an angle. So let's go ahead and jump into our first goal. Geometry is a math about shapes. We can measure shapes, compare shapes, move shapes, make arguments about shapes, and construct shapes. Constructions are done with a compass and straight edge. We build our argument using these tools. A compass is a tool we use to make circles which show equal distance. We can also use them to copy length. So this is what a modern day compass looks like. I bought this at Home Depot. I think it was $297 plus tax. In LA County, I think that's like 80% tax. I'm not sure. But you can make circles with this tool. It has a sharp point, and you can put whatever pencil or pen in there. That's why I like this compass. Now, if you do go buy a compass, do not go and put this on your nice dinner table and start making circles, because you're going to put holes in it. And don't go on your nice countertop and put this on the surface. You're going to put holes and scratches on it. And then you're going to have some explaining to do. Find an old book, not a family heirloom, but an old book or a notebook, and you put the compass on top of that notebook, and you spin it and make a nice light circle. You don't need to make it dark, but try and keep the needle in place and get that compass to spin all the way around and make a nice light circle. And when you do that, you've shown equal distance. And I'll talk about that in a second. Our second tool is straight edge. And what a straight edge does is it guarantees that the segment connects 2 points as straight. It's a real fancy way to say ruler, but we can't use it to measure distance. All we can do is use it to connect 2 points and guarantee that they're straight. That's all that a straight edge does in the world of construction. All right. So let's move on. Why do circles show equal distance? Well, by definition, a circle is a set of coplanar points that is equal distance to a point, that are equal distance to a point. Set of points that are equal distance to a point. I am just not very good. That are equal distance to a point. The center of the circle, that's the point that all the points are equal distance to, is the center point. Let me draw a circle with my compass. Now my compass is a yard. And I hold my thumb on the center, and I pull the pen along my compass, and it doesn't get any wider or any narrower when I make my circle, and that's what guarantees that all the points on the circle are the same distance to the center. So let's see if I can draw a circle with my compass, okay? I wish I knew how to do some fancy editing. I'd put in a drum roll. Drum roll, please. All right, so needle, and I'm going to make my nice, oh, they're not even close. That's all right. So there's my attempt at a circle using a piece of yarn. All right, so here's my center point, and any point, excuse me, any point on the circle, they're all the same distance from the center. And that's because that's how the circle's made. All right, so this becomes a very important tool. And again, when you see this, you're seeing equal distance. So let me go ahead and clean all this up, set up for our second goal, which will be accomplished when I show you how to copy length, and then we'll come back and talk about our third goal. So let me clean all this up, and I'll be back. I'm back. So let's go ahead and jump into our second goal here, and that's going to be to copy a segment. And remember, we use compasses to copy segments. All right, not rulers, but compasses. So copy a segment means to copy the segment's length onto another location. 2 steps to do this. It's really actually simple to do. Steps to copy a segment. Oh, cricket. First, open the compass so that the needle is on one end point and the pencil is on the other end point. Oh, I stopped cricketing. Awesome. Do not adjust how much the compass opens, and place the needle on the location where you want to copy the length. Here's an example I like to do. I'd like to copy the length of segment AB onto line L, which I should name line L. with this. There's line L. And I'd like to copy this length onto line L at point C. Really, really easy to do. So again, I have a compass that is a piece of yarn. So I will set my marker, put my needle, which is my thumb, on one endpoint, put my pencil, which is my marker, on the other, make a mark, come down here, copy it. I know that these segments are congruent. I'll name this point D. Okay. So by construction, by how I built it, I can confidently say that the length of segment AB, or segment AB, is going to be equal to the length of segment D, or congruent to segment D. So by construction, segment AB is congruent to segment CD, or the lengths are equal. The length of segment AB is equal to the length of segment CD. All right, so let me check off the first goal and the second goal. And again, this is how we use it to copy length. I wanted to wait till we got into this to show you. I'm going to come back with the second goal. It's a little bit more involved, but again, it's a neat little construction. So let me clean this up and I'll be back. I'm back, so let's go ahead and jump into our third goal here, and that's to copy an angle. And we're going to copy an angle using a compass and straight edge. So this seems like it's really long-winded, but it's actually really easy to do if you do it a couple times. So let me go through the steps. The steps to copy an angle to another location. First, put the needle of the compass on the vertex of the angle you want to copy and make an arc. Without adjusting the compass, place the needle on the point you want to copy the angle to and make an identical arc. So I will do that first step. So the first step is I want to make an arc, put the needle on the vertex, make an arc. Without adjusting the compass, make an identical arc. Make the arcs go just as far up as they do. That was the first step. Second, go back to the original angle. Excuse me. Put the needle on one point where the arc intersects the angle, and the pencil on the other point where they intersect. Copy that length. This is a length. That's why we need to know how to copy it. Copy that length where the angle copy that is. So let me try this again. So put the needle here where the arc intersects the angle, and the pencil on the other point where they intersect. Copy that length where the angle copy is. Needle goes on the line where the arc intersects. Okay. A little jumbled, but it's really this simple. Needle goes where the arc intersects. Pencil goes where the other arc intersects. Copy that length down to here. Okay. That's step 2. Then step 3 says use the straight edge to connect the vertex with the intersection of the arc from the first step and the length from the second step. So all I literally need to do now is connect point B to where these intersect. Email. And I have copied my angle. So what we're doing essentially when we copy an angle, the first step is saying how far out I want to measure. How far out I want to measure how much my angle opens, which is the second step. So I determine how far out I want to measure my angle opening. Then I measure how much it opens at that point, and then I connect my dots. That is how you copy an angle. So I'm going to erase this. I'm going to copy an obtuse angle, which is a copy that people struggle with, or a construction I struggle with a little bit. I'd like to show you that. So let me clean all this up, and I will be back. I'm back for the last time, I promise. So I did want to copy an obtuse angle just to show you what that looks like. And again, when we're copying an angle, we make an arc that tells us how far out we're going to measure how much our angle opens. We copy that arc onto where we're copying the angle. Then we measure out how much our angle opens at that distance, and we come over here and we copy that. We're essentially copying how much the angle opens at a certain distance. That's what this construction does. So let me go ahead and do this real quick, show you how to copy an obtuse angle. The steps are the same. And here we go. All right. So I'm just going to make an arc. The arc needs to be bigger because it's obtuse. I'm going to come over here and make the same length arc. Okay. 2 longer arcs. And then I need to measure how much my angle opens at this distance. So my angle at this distance, needle goes on one point, pencil goes on the other. My angle at this distance, see, there it is, opens up that much. Then we come over here and copy it. Opens up that much. All right, so now I'm gonna connect them up. And I have now copied my obtuse angle. All right, so I wanted you to see that, and that's pretty good. I think that's all right. I wanted you to see that, so when you do constructions, you have an idea on how to do obtuse angles. Now, the importance of this is we're going to get into the next couple sections on determining if triangles are identical through certain patterns. And the way that I want to approach this is I want to build triangles by copying sides and copying angles. And when we copy them in a certain order, you're guaranteed identical triangles, congruent triangles. So I wanted to talk about this lesson so when we see the next upcoming lessons, maybe they make a little bit more sense and we can wrap our mind around it a little bit easier because we can see, in fact, that we've built identical triangles. So I'm going to go ahead and end this lesson here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.